Hello everyone, good morning. In our previous class, we have seen containers inside pod can able to communicate with each other automatically. You don't need any external network device. Second thing, pods inside one node also can able to communicate with each other. Yesterday's class one, you can see here, containers inside a pod can able to communicate with each other automatically. It's a kind of you and your brother inside one room. If you want to talk to your brother, you don't need any electronic device, correct? Now here, this is your house. This is one room. This is another room. You are in one room. Your brother is in another room. So inside one house, even though you and your brother are in two different rooms, you can directly talk to him because both of you are in the same house. Correct? So in the same way, inside one node, pods can able to communicate with each other automatically. Pods means what? Inside containers. Indirectly, that's the meaning. Got it? You don't need any electronic device. That already we have seen in our previous class. So now actually we are entering into Kubernetes network. So in Kubernetes, we have an object called service object. Service object. Just like we have seen pod object, replication controller, replica set, deployment. In the same way, we have service object is there. In this, we have three configurations are there. Three configurations. The first one is virtual IP. Also, you can call cluster IP. Either you can call virtual IP or cluster IP. Remember these names. Second one, node port. Node port. And third one, load balancer. Load balancer. Fine. This is the object name. These are configurations which are available in this object. That means when you use this object, you have to mention what configuration that you are using. Either virtual IP or cluster IP or node port or load balancer. You have to mention clearly. Okay. So first we'll talk about virtual IP or cluster IP. Now let's see, first of all, why do we need this virtual IP or cluster IP? For that, you should understand the problem that we are facing in yesterday's class, in previous class. In previous class, when you observe this diagram carefully, this is a node, your base machine. Inside we have two pods, pod 1, pod 2. In each pod having one container, right? We have opened port of that particular container. By using pod IP, we have access to application inside running inside the container, correct? Let's say if you want to access the application running inside this container, we use this IP, pod 1 IP colon containers port 80. Okay, then your request will go through this particular port. You can able to access this application. If you want to access this application, then we have to use this pod 2 IP colon this port. Correct? So if you want to access application running inside the container, you have to use that particular pod's IP address. But the problem here is, what if I lose my pod? If you lose your pod, right, deployment object creates new pod. That already I need not explain again. If you lose any one pod, that's what healing we have seen. Auto healing. If you lose any one pod, deployment object creates new pod. But new pod will have new IP. So every time can you remember that IP? No, that is impossible. That means every time pod is getting crashed, new pod will get created automatically. Till here, no problem. But the problem is new pod will have new IP. Can we remember that IPs every now and then? No, we can't remember those IPs every now and then. So what we need any one fixed IP. We need any one fixed IP so that doesn't matter, backend pods may get terminated and due to auto healing, new pods will get created. But front end, I need one fixed IP. For that, we are going to use a concept called virtual IP or cluster IP. So what actually happens here? Let's say this is my node, base EC2 instance. We are talking about virtual IP or you can call cluster IP. Cluster IP. So here I have two pods. Pod 1, pod 2. Each pod is having one container. This is container 1. This is container 2. So let's say in container 1, we have HTTPD is running. In container 2, we have Nginx is running. Nginx application, just like Ola, Uber, Zomato, Swiggy, kind of. So HTTPD, Nginx is running. Now, anyways, we are opening ports right here, 80. You know, to access this application, we have to access through port 80. Now, here what we do, when we use cluster IP or virtual IP, Kubernetes allows us to choose any one port. Kubernetes allows us to choose any one port. That port we call service port. Remember that. You can choose any port. You know, right? We have total 0 to 65535. These many ports are there. These many ports are there that already you know. Already we have discussed earlier. Out of these ports, you can choose any port, whatever that you want. So what I'm doing, I'm selecting one port. Okay, let's say that port also I'm selecting 80. Any port, your wish. So what is this? This is what service port. Now Kubernetes will give one virtual IP or cluster IP. Will give one virtual IP or cluster IP. This is my node. Let's say I'm just writing VIP. Okay, virtual IP I'm writing. Kubernetes will give virtual IP. Kubernetes will give one option to you to choose service port. Now what actually happens here? This service port will be mapped to container ports automatically. And this service port will be mapped to virtual IP. This is what actually happens. Understood? This is service port, which is mapped to container ports, and virtual IP is connected to service port. Service port also port number 80. If you want to access application inside container 1, you have to use virtual IP, VIP, colon, this port 80. Service port, virtual IP, colon, service port. When you use virtual IP, colon, service port, then request will go to which container? That's what it acts like a load balancer. One request here, one here, one here, one here. Okay, in browser, when you pay this one, when you hit refresh once, one time you will see Swiggy, and the other time you can see Zomato, like that. So it's kind of load balancing. In real time, what we do, we keep same website only, Swiggy only, so that load will be distributed to both the containers equally. That is how things work. I'm repeating, when you use virtual IP, colon, service port, then the request will go to one container first time, second container second time, like that. That is how load will be distributed. Let's say if I lose my pod, and you know, right, deployment object will create new pod, correct? So new pod will get created with the template. That means same template, means same HTTPD port 80 will be opened, template remains same, correct? Then automatically the new pod will be connected to service port automatically. That means every time when you lose pod, new pod will get created. That new pod will get connected to service port automatically. You don't need to worry about backend. Pods are getting terminated, new pods are getting created. Every pod is getting new IP. No, for us it is unnecessary. Okay, we don't even need to worry about pods IP addresses. Front end, they are giving one static fixed IP, that is virtual IP. Okay, that will get connected to new pod whenever it gets created automatically. You need to worry about only virtual IP colon service port. These are fixed, right? So that is how things work. That is how we are resolving the issue of losing pods and new pods are getting created. Got it? Let's do it, then you will understand. Let me log into AWS account. Next, sign in, submit. That's it. Now go to EC2, instances, start your instance. Select instance state, start. Now connect. That's it. So now I have logged into my EC2 instance. Now sudo su minus, then start minikube. Minikube start -- force. That's it. Fine. Now clear the screen. First verify kube ctl get all. Do you have anything running? No, we don't have anything. Correct as of now. I'm going to create one deployment file. Okay, you can give any name to that file. So I'm giving deploy httpd.yml, in which let me paste this script. So what actually I'm doing here, I'm creating deployment object, and you know that that comes under version v1, and this is the name of the deployment. Already we have discussed deployment object, and here replica. So how many that your wish. As of now, I'm taking one replica. You can choose whatever replicas that you want. And you know, right, this particular selector should match with this label so that this replica will be created from this template. That means you will have one pod having one container having port opened. Which port? 80. And inside container, what is running? HTTPD. Correct? Fine. This is going to be your setup. This is my node. Inside, what is the name of pod? Pod name will be taken automatically, as you know. Inside one container as of now. What is the name of container here? C00. So inside container, what is running? HTTPD and port 80. We are opening port 80. Fine. Now let's apply this one. You know how to apply? kubectl apply -f deploy httpd.yml. That's it. Now if you verify kubectl get all, you should able to see one deployment object, and you know deployment object creates replica set object. Replica set object creates pod object. Correct? So right now we have given replicas as one. That's why you can see only one pod. And this is your deployment object name, and replica set object will have deployment object name as a prefix that you know, and pods will have deployment object name and replica set object name as a prefix. Then at the end, some unique, letters. Now I'm going to create service object. Let me create one manifest. VI service object. What is the configuration of service? The configuration of service would be virtual IP or cluster IP. Service.yml, in which, let me paste this script. Now observe carefully here. Type of object service. Object name is service. Service object comes under version v1. You have to mug it up. Name that I'm giving to the service object is demo service. So here you can give whatever name that you want. Your wish. Now, spec ports, this is fixed. You have to mention as it is. Now, target port means what? See, here I have mentioned comments. That is for your reference only, for your understanding. Target port 80 means in deployment object, in container you have opened one port, that port you are mentioning here. I'm informing to service object that, hey, service object, in my container I have opened this particular 80 port, container port. And I told you that service object is giving one option to you to choose service port, correct? That is this port 80. Okay, you can give whatever port number that you want, your wish. As of now, I'm taking port 80. Got it? So this is container port that you have already opened. This is service port that you can choose whatever port that you want. And what is this? This is that selector. You remember, right? In deployment object, you have given label. That label should match with this selector. One more thing. Here we are creating cluster IP. Object is service, but what configuration of that object? Cluster IP. Also, you can call virtual IP, but you have to mention cluster IP only here. I mean, official name cluster IP. So this cluster IP will be mapped to that deployment object. Because see, there we have given label, here we are giving the same selector. Understanding, right? Okay, let me come out, then I will show you by keeping these manifests side by side. Cat deploy HTTPD. These are manifest. And cat service. Let me reduce the font. Now, observe carefully here. This is deploy HTTPD manifest. This is service. This is my node. Inside, this is my pod. Inside, this is a container. We are opening port 80. Inside container, HTTPD is running. This is node. This is pod. Whatever port you are opening for the container, that port should match with this one. See, I have mentioned containers port. I'm informing to service object that, hey, service object, I have opened port 80 in my container. So I have opened port 80. Then service is allowing you to choose one service port, that is port 80. Means I am selecting port 80. This is service port. Then what type, what configuration of that service object you are creating? Cluster IP. Either you can say configuration or type. Service object I am creating, but what type of service object? Cluster IP type. So here cluster IP. This IP now will be mapped to this port. This port will be mapped to this port. Now you must be thinking, Sai, how these two will be connected? What is the connection? That is what here selector. Name equal to deployment. That should match with this one. Name colon deployment. See, here I have mentioned clearly. This one, whatever you are giving, that should match with this one. This label should match with this name. So that this replica will be created from this template. And also, this also should match with this one. So that these two will be connected. This service port will be connected to these containers, this port. Focus on my blue color. This service port will be connected to this container port. Why these two will be connected? Because we are giving the same label. Whatever label you are giving, we are giving the same label here as well. Okay. So whenever label matches, this will get connected to this object. Means these two will be connected. That's it. Over. Game is over. Now let's apply the service object. kubectl apply service. That's it. Done. Now what actually happened here? Port 80. Service port. Service port got created and virtual IP. Virtual IP anyways will be connected. Now these two got connected now. That's it. So connection is virtual IP to service port to container port. Okay. So here virtual IP. Understood? How to verify now? But now I told you, right? We can use virtual IP. We are inside the machine. See, virtual IP, it works inside. Now verify kubectl get all. kubectl get all. For the first time, see, this is a default service. This will be there by default. Okay, now we have created new service. What is our service type? Cluster IP. Cluster IP we have created. You remember, right? The name of the service we have given demo service. Now service configuration type is what? Cluster IP. And what is our cluster IP? That is this one. 10 series means what? Private IP. Cluster IP is a private IP. Already you know 10 series means starting with private IP. We have discussed already. Okay. And this IP is mapped to this service port. This is service port. That means you can use this IP colon the service port in order to access the application which is running inside the container. This IP colon this port. So VIP colon this one, service port. So let's try to access, then you should be able to see default HTTP page. Curl IP address colon port 80. Now press enter. You can see it works. Working fine. Now how to verify whether it is working fine or not? I mean, how to verify whether when new pod gets created, that will get connected to this service port or not. How to verify? So what we do intentionally, let's delete this pod. I'm going to delete this pod. You know, right? When you delete pod, deployment object will create new pod. Auto healing works, right? Backend. So deployment object will create new pod. That new pod's 80 port, that means pod inside containers 80 port will be automatically connected to this service port automatically. That means now you just have to remember only this part. That's it. You don't worry. Backend ports are getting terminated and new ports are getting created. Let me show you. If you want to see this pod IP address, kubectl get pods -o wide. See, this is my existing pod IP. What I do, let me delete this pod. How to delete this pod? kubectl delete pod name. enter. See, pod name ending with HP, I'm deleting. Deleted. Now, remember, IP address ending with 0.4, correct? Now, kubectl get pods, get all. See, new pod got created. Earlier it was HP, now it's 9L. What is the IP address of this pod? 05. But it's unnecessary for us. What we have to do? When new pod got created now, that pod inside containers port 80 map to already service port. So you have to use this virtual IP colon service port. Verify. Curl. This is virtual IP colon port 80 service port. That's it. It is working. Now whatever web content that you are seeing, right, that is from new pods container, because old pod already we have terminated. This you are accessing from new pods container. That is how things work. Got it? So you don't have to remember pods IP addresses. We are getting one fixed virtual IP or cluster IP. You must be getting one doubt. Sai, what if I have multiple pods? Same thing. This is what actually happens. Replicas, we had given only one replica, correct? If you open this file, cat deploy HTTPD, in that, what do? You give multiple replicas. Let's say you give 2 or any number. When you give 2, this is what going to happen. That means here, template is same. That means in both containers, HTTPD only will be there. And in both containers, which port will be opened? 80 only. Correct or not? See, total 2 pods. Each pod will have one container, C00, having port 80 open and HTTPD. Yes, same thing. Now this will be connected, both will be connected to the service port. Then what actually happens? Load balancing happens. You hit refresh, you just type once here. Then you can see web content from one first container. Again you try to access from second container. Again first container. Again second container. But you won't find the difference because both are having same web content. That is what actually happens when you type Uber. When you access Uber, you also can see Uber page only. When I access, I also can see Uber page, because in all containers, same web content will be there. Got it? So that is all about virtual IP or cluster IP. But here there is a problem. We have a problem here. What is the problem? This virtual IP is a private IP. This you can access only from inside the machine, inside this node. See, these are private IP, correct, on a 10 series. You can't access from outside. You can access only from inside this machine. But how to access? I want to use this IP outside in the browser. Okay, so then how to access? You can't use private IP in browser, right? That will not work. Then how to resolve this issue? Yes, to resolve this issue, we have second configuration called node port. So whatever problem that we are facing here, we have resolved first problem. That is, even if you lose any one pod, new pod will get created. That will be connected automatically. But the problem here is you can't use virtual IP or cluster IP to access from outside the world. Outside means out of the machine. So to resolve that issue, we are going to use node port. Okay. So let's discuss node port now. For that, let me delete this deployment object, both kubectl delete -f deploy HTTP. So I'm deleting deployment object and also service object. Service object. Fine, we have deleted.